All right, so as we said yesterday, I'm just gonna, for that due date section of your plan book, you could really just write like 1, 2, 3 in parentheses or whatever code kind of will help you remember that those 3 assignments will be collected with each other. And when might I ask for those? Friday, right? Yep. You are correct, because that's tomorrow. That's the future. The future. All right, so unfortunately, the printout didn't print, but let's analyze this data for a second. So, hands off anything. You don't need your ruler in your hand. You don't need your pencil in your hand. Let's just look at what this table tells us. So Nate's been watching car ads, right? He's curious about odometer reading. What's the odometer? Who knows, Henry?
An odometer is a machine that calculates the distance that an object has traveled.
Yeah, so on the car it tells you total in the whole life of the car, how far it's traveled. No, that's the tripometer. So you are correct, but that is a trip odometer. So there are 2, and I love that you just brought that up. The odometer section of and depending on how fancy your parents' car is, it might be digital. But if it's an older vehicle, like what I drive, you can just get in and the car's off. And it's got a little dial that literally just turns numbers as you go. And it's got 6 numbers on it. So it can go up to 999,999. But if you drive your car 1,000,000 miles, it'll look like you've gone 0. Because they don't put a 7th digit. Because how many people do you think drive their car 1,000,000 miles? Probably brakes first. Really? Your mom drove her car 1,000,000 miles?
We drive a lot.
Yeah, I mean, some cars, they like, you take good care of it, and you just do all the maintenance, and you can, like, Toyotas, Hondas, they've been known to drive 1,000,000 miles. So, what do you think? Make a prediction in your head right now. Would a car with a lower odometer number, presumably newer, be more or less expensive? With that prediction in your mind, look at the table. And that's in thousands of miles, right? So this 35 means that car has traveled 35,000 miles. My vehicle just rolled over 90,000 miles. So if you're trying to figure out like what's average, a new vehicle has 0, right? It hasn't been driven. They typically say a car will travel about 10,000 miles in a year, like on average. Somebody just did the math. They said, how far did you go? How far did you go? And on average, people travel like 10,000 miles a year, or like under 1,000 miles a month, right? So if you go home and ask your parents, you could do the math. You could say, hey, how far do you think you drive each day? And then you could compute that out. On the weekends, they may not drive as far. They might drive further. But so 35, 38. If we go way low, only 6,000 miles traveled. Is that price more or less? More. If we go higher, like 99,000, closer to like my vehicle, more or less? Less, right? Less price. That's only $10,000. And then this vehicle might just be a better vehicle. Same distance traveled, more expensive by $3,000. Do we see anything here that doesn't look like it makes sense? Like, we always want to be looking for outliers. Simon?
So the one that went 15 miles only got like 28,000 for it, but the one that went 31,000 miles, which is right next to it, is worth more than that.
Oh, so you're saying these two, this traveled further, but is worth 35. This is newer, right? 15,000, but is worth less. Why might that be? Go ahead, since you noticed it.
Yeah, different cars just have different values, like automatically. Sometimes just cars are nicer and they can last longer. It doesn't necessarily just have to be about the newness of the vehicle.
Yeah, and the type of vehicle. What do you think is a like more expensive type of vehicle? Like? Okay, well that's a specific brand and like car, van, SUV, truck. Like, what do you? Henry?
semi with 2 trailers.
Yes. Okay, now we're getting outlandish. Hazel?
A smart car.
Do you think it's more expensive or less expensive?
Self-driving car would be more expensive.
Yeah, and those are barely even out yet. So here's the weird thing, though. Cars have crazy variability in how expensive they are. I can go get a brand new vehicle, but if it's really simple, it might be cheap, like $10,000, $15,000. But if it's a brand new vehicle, like still car, but really, really nice, leather interior, computer, Bluetooth, the whole thing, might be more expensive. And then as those vehicles age, obviously the one that started cheaper is just going to keep getting cheaper. The one that started more expensive, it starts to come down a little bit, but it started way higher. So, all right, so we have that. His evidence was that his car with 23,000 miles was worth more than Rick's car with 31,000 miles. Do you think that's necessarily true?
No.
Who can speak to that? Who wants to give their opinion of whether they think this is true? That Nate's car is going to be worth more than Rick's. Charlie?
So, with it being miles-wise, his car would be worth more than Rick's, yes. But the design and, like, the modernicity and the simplicity, all that is all variables.
Yeah.
With that.
And did Nate paint his car with like a can of spray paint versus like, there's a lot of things we don't know. So there's a ton of variables here. Like you said, there's
You're in a wreck, that'll bring down the car too.
exactly, yeah, if it's ever been in a wreck or if it's been in multiple wrecks and that whole thing. So Melissa's like, all right, guys, you're being silly. You're just staring at numbers. Let's do something with these numbers. So Melissa's like, look, I have created a beautiful box plot for each of your sets of data. They had odometer readings. They had price. I want you to take a moment on your paper, and then we'll turn and share, but I shouldn't really hear anyone talking after I tell you what to do. Write about, is this, like, what can we do with this? Is this purposeful? Did Melissa help us out? Did Melissa kind of waste her time? Like, what can we do with this? Does it help Nate and Rick figure anything out? What do you think? Box plot, right? Box-and-Whisker. May have used to be called.
Yeah.
And this is 714. If you're trying to keep track, that used to be my area code back then. 614 is our area code. And because everybody loves random cards, give you another couple minutes. Now with the warning of I'm going to randomly call and ask for you to share your opinion. Huh?
You randomly pick my card. You gotta stop shuffling.
Oh, you're right. Until I work my way. I need a marker card. Yeah, they tell me where the start was. So here, this card actually, well, that's too small. There we go. This joker will mark the start. Alright, so to start with, Serena, you get probably one of the toughest, well, I don't know, maybe one of the toughest questions. What's a Box-and-Whisker plot show us? Why the boxes? Why the whiskers? What's going on? I'm going to take one issue with one word you use. Stop using average. Pull the word average out of everything you just said, and I agree with you. So, middle, I totally agree with. The middle of the two halves, I totally agree with. But stop saying average, and you're all good. So, the problem actually here is averages, like, averages help us. But this doesn't actually show us average. It shows us something else. Kind of like average, but Alina?
It's the median, and they show the quartile 1 and quartile 2. But also,
Well, now what are quartiles 1 and quartiles 1 and 3 actually?
yeah. It's like they're like
Yeah, so really quickly, and not as sloppy as my giant marker that somehow pulled up, draw a box and whisker on your paper. Just literally, that's all you have to draw. You don't even have to draw the line. This is just a reminder drawing so we can like get our brains back on math. As we heard from our classmates that have brushed the cobwebs off, this is the minimum. This is the maximum. This is at 25% of your data. This is at 50%, or the exact middle, and this is at 75%. It shows us concentration. My shoulder hurts like crazy, and I'm still writing. Those of you sitting there just staring, pick up your pencils and write. I don't know if it's rock wall last time. Huh?
It looked like the towel for a second, then I realized that I was next to it.
Yeah, my pen, if I don't lift it far enough,
Why does your arm hurt?
shows concentration of data, or width. So concentration means how much data and how spread apart or close is it. Each of these sections have equal amounts of data points. So if, as close as possible. So if this has 5 of your data points, this has 5 of your data points, this has 5 of your data points, and this has 5 of your data points. It's breaking your data up into even chunks. But if this box is really small, that means all 5 of those are super close together. So when we look up here, okay, really tight concentration here. Why? Who can talk about why you think in price we see 25% of all vehicles for sale are in that little range? What do you think, Alex?
Because not the first one, but the second one has used like a wide span of numbers.
Okay, this is a lot wider, that thing, but this is still 25%. So there's equal amounts of vehicles in here.
And the first quartile is, or like that first section, all the numbers are much closer together. They are, but they're still.
Why do you think they're tight there instead of tight up here? Josh?
It might be like a dealership that sells like.
This is all dealerships. Well, we're assuming. Now I know they said he looked at ad data, but this would work for, this would make sense for any. Let's assume we're looking at all cars for sale. When a car gets sold for the second time and it's used, is that price higher or lower than it was? So these are all vehicles for sale, right? They were talking used. Is this cheap or expensive? It's cheaper, right? In the realm of vehicle prices, people want a good deal. When you walk onto the car lot, it's not a bunch of cars for $50,000. It's a bunch of cars for $12,000, $15,000, maybe $16,000. And when you bump up into this price range, that's a whole different, like, okay, now I'm willing to spend more money. Now I'm willing to spend like $20,000. Then there's a whole nother bracket of cars here that are pretty close together, but that's like your trucks, your minivans, your SUVs that are like just naturally kind of expensive. And then up here, probably like your sports cars. You're really nice, really fancy. Notice how wide this is. These $50,000 is a lot. It's a lot for a new vehicle. That's like an Escalade. Like I'm like not joking, just out of reference. Like that's probably like a Cadillac Escalade. Yeah.
But wasn't the original question whether this proves Nate and Rick's point?
Yes. So circling back to that, I just wanted to talk about Box and Whiskers for a second.
But the issue is it doesn't, because if the two box plots don't have any data point coordination. The thing is, you don't know.
Yeah.
Oh yeah. You don't. It doesn't show you if this applies to here, 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 here. It could be anywhere within this range. There isn't enough coordination between the two.
Actually, it's most likely the minimum point on the odometer is one of the higher points on the price. right? So exactly what Henry said. This is all a waste of time. Not a waste of our time. It was a waste of Melissa's time. I wanted us to review Box-and-Whisker plots because we use a lot of different graphs this year, and a lot of people mess up Box-and-Whisker plots. So guys, if you are at all rocky on this, and I were to give you advice of 2 things to write down, the 2 things for Box-and-Whiskers is it splits into 25% pieces, splits into quartiles, right? It takes your data and chunks it into fourths. And that it shows concentration, shows, trying to think of another synonym. Synonym? What's another synonym for concentration? Like, yeah, it shows like range or tightness or whatever of your data. All right, so now knowing that Melissa wasted her time, we have been called in to help. So because we told Melissa she wasted her time, she got upset and she ran away. Well, I mean, come on, we didn't. I didn't really say it very nicely. I told her straight up, Melissa, you wasted your time. So, on your graph paper, and I'd maybe say probably flip to the back because we're going to need a lot of it. Here's how we're going to set up our X and Y. And we only want coordinate 1. So we're only drawing the top right coordinate. Or the top right quadrant. Hey, check this out and then draw. Don't start drawing and not listen to directions. We want everyone's graph to look the same. Please just follow directions. I don't want to have to collect this like as a practice assignment. So if you have something not a pencil or a ruler in your hand, you shouldn't. X-axis. Every 2 boxes is 10. So you want to go up to 100. Y-axis. Every 5 boxes is 10. Or you can tell yourself each box is 2. So you want to go up to 60. Okay? X-axis, Y-axis. So this will go up to 60. You don't know what K stands for? You might if you play like Madden 2K7 or actually they probably stopped using 1,000, right? So like back when I was in school it was like Madden 2K2.
They don't do Madden anymore. They do NBA.
Yeah. Well, now we're so far into the thousands. And then if I'm okay to change this screen, we want to plot Nate and what's his face's data. Rick and Nick or Rick and Nate or
Rick and Morty.
Rick and Nate were last episode.
Wait, what was the
here?
So remember, your left column, your odometer reading, that's your x-axis. And your y column is price. Right, so these are your x's, these are your y's. So I'm going to write out just coordinate style. We have 35, 38. So K means 1,000, right? So that's price in thousands. Every number there is actually thousands.
What's the mile abbreviated again?
MI.
The x-axis, what was the
Odometer or miles. Oh, the scale. Every 2 boxes was 10, or each box was 5.
MIK.
Everyone have their axes. Tell just read your points to help you out.
Wait, so how far did the y-axis have to go up to?
60 if you can. If not, it's okay, but we get close to that. So because I did get at least one of these copies to work, I will do it with you guys on the dot camera. Yep, scatter plot data. Those of you making extraneous noises, you're not helping. So something like that. I think I'm missing some points.
I got one like that. We got the one that's by 50.
Yeah, 650.
It's like,
And 28, 30.
there's like three outliers.
I might have them all. What do we notice about this data?
There's like three outliers and the rest of them kind of bunched like in between 60 and 10.
Now, what do you mean there's 3 outliers and the rest of them bunch?
Okay, so the one that's all the way up by 50 on the y-axis, I think that's one outlier.
Now, actually, let's back up and say, what do you mean by outlier?
They're out of the group.
What do you mean the group?
The
What do you mean the dots? No, I mean, I'm just teasing now. So, here's the only issue I'm taking. Are you grouping like this as like a circle?
No.
Because if I was like, you know, trying to get a merit badge and trying to group, like if I was shooting at a target, yeah, that's a grouping. But when we talk about graphs and behavior, we're thinking in lines, right? So when we look for a group, we actually want to look at a group that its behavior kind of travels together. Have you guys talked about line of best fit in science yet?
Yeah.
I was about to say, I've been told that you have. Mr. Cabilo has says that you have had that discussion. So a line of best fit is the line that would best go through this data. So most of you could probably tell me this would not be a line of best fit. Most of you could probably tell me this would not be a line of best fit. What was our prediction when we started the lesson about cars as they get older or get more miles? They go down in value, right? So we would assume our line of best fit will have a downward sloping trend. If we try to include this point, and I think this is what Liam's getting at, we have to push this way up. Or if we leave it out, we could change our slope and kind of level off. If we try to include these points, kind of got to push this end down, but that doesn't seem bad. Does anyone know the strategy for finding line of best fit? Simon?
You should have the same number on the top as you have on the bottom.
Try to balance out points on top and points above the line and points below the line. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I try to go like 4 above, 4 below, and maybe 1 on. That works. You can't see all the points because of my ruler. But 1, 2, 3, 4, and then 1 on. 1, 2, 3, 4.
Should we draw that on the paper?
Yeah, if you want to try to sketch something that looks like it follows that behavior, go ahead. I'm not. I think 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's 9. The graph does not look very crowded. Like, I will say that. We're used to graphs that have a lot more points. So, if we go back to the initial question, kind of Nate with 23,000 miles, how could we give Nate a prediction of what he expects his car to be worth? I can't call on Simon again, guys. We just talked. Looking for someone that hasn't spoken up yet today. Josh. What? Oh, Patrick. Sorry, your peripheral only goes so far.
You follow the line of best fit.
We follow the line of best fit and look for what?
How many miles this car has?
So we find 23, and this is easy if you have a ruler. Find 23 and go up to our line of best fit. This is what we will call a prediction point, right? For Nate, I think it was. And then find a prediction point for Rick.
Wait, so are we assuming none of these cars have been in wrecks and are in good condition?
We're assuming that we only know what we know. Is the safest thing I can tell you.
We're assuming that we're assuming anything. Yeah.
Like, yeah, there might be an outlier point here that's been in an accident. Like, this point down here may have been in an accident, and that's why it lost so much value compared to this point. But we don't know. So what I'm saying is we only know what we know, but we're operating line of best fit with the data we have. So for 31,000, we'd come up here. Right, isn't that the other mileage? Yeah, for Rick. So according to our graph, yeah, okay, what they say is probably true. But as Liam and a lot of people have talked about, there's a lot of variables and condition things, and like there's a lot that's going to go into this. Now, this vehicle, I would argue, is an outlier. That's probably some crazy fancy sports car like a Ferrari, a Lamborghini, something that, and this, no, hold up, don't jump down my throat yet. This already had an owner, right? Somebody owned it, and they drove it for 6,000 miles. I'm not joking. A fancy car like that depreciation from brand new to somebody else, like, it's not new, right? So those hoity-toity fancy people that want to buy those cars, that drops the price a lot. So that might be, like, that's a used car. It's got 6,000 miles, but it's still worth $50,000. That's something fancy. Henry?
But the reason that those cars are so rare is that it creates a volunteer's dilemma, whereas nobody wants to buy it new. Everybody wants it used, so therefore nobody will buy it new, and they're very rare.
Nobody, right? So that's the thing, is like the nobody that you're saying is that very small population of people that can afford it and don't care about getting a good deal. So what you're saying is totally true. Did that come from that book I gave you? Yeah. So I gave Henry a book about statistics, and it's very interesting. What he's saying is, like, if you create a situation where nobody wants the new thing because nobody can afford the new thing, like, okay, I'll use my brother as an example. My brother, just like a year or two ago, bought a Porsche. Ooh, not really. Because it's a used Porsche. It was affordable. He could buy it. And, like, it wasn't, like, as cheap as my vehicle. But it wasn't $50,000. It was a used by multiple people. He would never buy a new Porsche. But there's a market for the used vehicles. That's kind of what Henry's saying is like, there's a very small population getting those new vehicles, and then they kind of get on to other people.
Car company was, they're out of business now, but
Huh.
they...
You saying that's just funny?
You'll hear why. They started making a car, and the car wasn't getting enough customers because they would just resell it to people who wanted it for resale.
Oh, yeah. So check...
So they weren't getting enough, and so they put faulty engines in just so that they would like have more people buy more of them because they're kind of cheap. But
You sure you're not talking about the Volkswagen clean diesel scam? I don't know that a car company would ever put a faulty engine in a vehicle, but Volkswagen got in big trouble because their clean diesel engines were not clean like they were saying they were. But all right, we got to move on because I could talk about this for way too long. On your paper, letter A, B, C, D. Or number I, or ID. But A, B, C, D is easier. We will call these graphs 1, 2, 3, and 4 to make life easy. Because if you don't know your Roman numerals yet, that's what those mean. So, sorry, no time for correction. It's as close as you get. So, you doesn't need talking to go with it. You need to determine which situation matches which graph. And then be able to defend when I random cards why. Take 90 seconds. I bet that's plenty of time. Anyone still need 711 or 712? So, for the sake of time, because we're running out of it, and you get to pick which one you want to talk about. Mr. Dale, tell me a match that you made and why.
Alright, for A, how fast can a dog run and the length of the dog's fur, I put that with the I thing, simply because I feel like if the hair is longer, there's going to be more friction and just air drag, so the longer the hair.
Who watched the dog show at Christmas? Nobody? The Westminster dog show, oh my gosh, you guys are breaking my heart. Look, after the parade, there's a dog show, and it's like the... Oh, maybe it is Thanksgiving. Oh, they rerun it at Christmas. Sorry, that's why it was on at Christmas. They rerun it. Yeah, so at Thanksgiving. Look, I'm getting old. I'm getting okay. So these really big, really fluffy dogs that with tons of hair, while they're big, the hair gets in their way. So I think I would agree with what Alex says. We could probably match II and A for how fast a dog can run relating to it. This is their fur length, and this is their speed. Short fur like a greyhound. They have very short hair. They run really fast. My dogs have medium hair, and they run like decent length, but I'm trying to think of like Beethoven-esque dogs. I forget what kind of dog. Like they probably can't run that fast. They're big and they will totally topple you. But yeah. Logan, give me a match and why. We're not able to pass here. Were we on task or off task? So do you have it? It's okay if you need to like look back at it, but or do you want to pick one and you reason through it? Because B is a person's age and their body temperature. Do you think age and body, like, do you think as age changes, body temperature changes? D goes to I. Yeah, to I? Or D goes to I? Okay, sorry, I was looking at B. D, outdoor temperature and the percent of people wearing long sleeve shirts. That would make sense. As it gets colder outside.
But it could be getting warmer. We don't know what the scaling is.
You don't look now. Hold on. So they're going up together. We think C is I.
I agree.
So wait, those of you that don't think D is I, where should D go? 3?
I think it should go colors. Yeah, because people choose to wear whatever they want. Well, yeah, true. Okay, actually.
Is it hot or cold outside?
Cold and
Cold.
I'm
in short sleeves. You're in short sleeves. You're in short sleeves. You're in short sleeves. I think. Yeah. Now here's the only issue. We assume this is going up, so this would be like increasing temperature. So yeah, that is the only problem with that. Now, why? Who said C goes to C goes to I? Scream why? Yeah, not like now. It does stop happening, right? My feet have been a size 11 for a very long time, but notice what it says: child. So, like a lot of you guys will end up taller than me and with larger feet, but not right now because you're young. Actually, some of you might already wear a 10 or 11. Yeah, see, that's. I'm not surprised. Eventually, they stop. And then, hold on, let's check this. Does B go to 4, and who can explain why? We haven't talked yet today. Hi. Happy Tuesday. Why would B go to 4?
Because your body temperature usually stays the same. So, yeah, hopefully.
unless you're like incredibly sick.
Yeah.
What's that body temperature supposed to stay at? 98.6 is your average body temperature. Which, on that note, I will leave you with: if you have a fever, don't come to school. Love you guys. Have a great day. Nope. I will record it and email it to you, Charlie. Don't break my rulers while you're putting them away.
I just got a vaccine at the doctor's office yesterday, so I probably go to give you a chicken pox.
Well, that's not how that works.
I went to